Distinguished guests, respected professors and scholars, good day. I'm Jamalova Nurullayevna from the University of Innovation Technologies. It's an honor to stand before you at the second international conference on Nexus of Data and Information Technology. Our theme this year, Digital Intelligence for Sustainable Development and Societal Impact. Today we are not just talking about big data, complex algorithms, or machines. We are talking about building human capability and connecting people across the globe. When we think of digital intelligence, we often think about smart cities or big data. But I ask you to consider another infrastructure, human communication. To build a sustainable future, our youth must be able to share their innovations and collaborate globally. And the English language is the language of collaboration. In Uzbekistan universities, we meet problems. Students can read and understand beautifully, but they have some struggle when they speak their ideas. Traditional classrooms and speaking anxiety hold them back. This is where our research comes from. We have built a digitally integrated ecosystem where a modern bridge that turns passive learners into active ones and makes them confident. Before we look how the system works, let's first understand why this problem exists. Look at slide 1 to see how we are changing the way we teach. English as a foreign language speaking proficiency is a pivotal competency in higher education that underpins effective academic communication and fosters global engagement. In the context of higher education in Uzbekistan, learners exhibit pronounced microskill asymmetry, characterized by relatively strong receptive abilities and markedly weaker productive skills, particularly in speaking. This imbalance is compounded by the institutional and the psychological constraints, such as speaking anxiety and limitations inherent in traditional communicative teaching methods, which inadequately address learners' affect and motivation. Consequently, there is an urgent imperative to adopt a digitally integrated pedagogical paradigm that leverages technological affordances to enhance interactive practice, real-time feedback, and learner autonomy in the classroom. The problem centers on the persistent imbalance between learners' high receptive language and their comparatively low productive language skills. Despite extensive input exposure, learners often struggle to actively produce language-hindering effective communication. Existing pedagogical approaches have limitations, including insufficient emphasis on productive practice, lack of integration between receptive and productive skill development, and inadequate adaptation to diverse learner needs. Despite the growing interest in mobile-assisted and artificial intelligence frameworks within modern EFL environments, a significant research gap persists regarding the lack of fully integrated end-to-end digital solutions in formal speaking pedagogy. Current implementations predominantly relegate digital applications to fragmented and informal tools rather than to unified institutional systems. Consequently, contemporary frameworks struggle to overcome enriched oral instructions obstacles. Crucially, the existing literature fails to provide systematic models that concretely maximizes student talk time during synchronous sessions while executing continuous data-driven formative assessment, leaving the university learners without structured, scaffolded pathways to resolve acute productive deficiencies. Flipped classroom frameworks have demonstrably optimized EFL oral performance by relocating passive instructional content to autonomous pre-class environments, thereby fostering heightened learner self-confidence and engagement. This pedagogical shift aligns with Bloom's revised taxonomy, which provides a critical cognitive scaffolding structure that guides learners from foundational knowledge retrieval during asynchronous phases to higher order skills, such as analysis, evaluation, and creation in synchronous communicative settings. Empirical evidence underscores the model's efficacy in maximizing active learning, enhancing tertiary student satisfaction, particularly benefiting lower achieving cohorts through scaffolded and learner-centered approaches. Recent advancements have further integrated AI-powered and gamified elements within flipped speaking courses, augmenting interactivity and personalizing feedback mechanisms that catalyze oral proficiency development. Collectively, these studies substantiate a transformative reconfiguration of oral pedagogy that systematically elevates productive language used by leveraging digital autonomy and structured cognitive progression. The current literature reveals significant gaps in the integration of digital solutions within EFL speaking pedagogy, particularly the absence of cohesive models that unify an asynchronous and synchronous learning phases to effectively enhance productive oral skills in target language. While mobile-assisted and AI frameworks have gained traction, existing approaches remain fragmented, lacking systematic incorporation into institutional curricula and failing to maximize student talk time alongside continuous formative assessment. The novelty of proposed study lies in its innovative combination of a learning management system, LMS, with digitally operationalized cognitive phases grounded in Bloom's revised taxonomy. This fusion facilitates a structured scaffolded progression through 6 discrete cognitive stages: remember, understand, apply, analyze, evaluate, and create, within a flipped classroom framework, thereby orchestrating a seamless transition from pre-class knowledge acquisition to productive in-class communication. This integrated model addresses the critical need for a balanced, data-driven instructional design that simultaneously promotes oral proficiency and formative feedback in a digitally mediated environment. The primary aim of this research is to optimize EFL speaking proficiency among university learners in Uzbekistan by addressing existing micro-skill asymmetries through an integrated digital instructional framework. This framework seeks to enhance productive oral skills by leveraging a cohesive blend of technological tools and pedagogical strategies tailored to specific linguistic challenges faced in the context of this study. To achieve these aims, this study addresses the following specific objectives. The study aimed to conceptualize and engineer a digitally integrated instructional model that synergistically amalgamates in LMS-driven flipped classroom framework, Bloom's revised taxonomy as the cognitive scaffolding mechanisms, and the proprietary tsunami growth dynamics method to optimize learner engagement and scaffolded cognitive progression. To rigorously empirically evaluate the hybrid model's efficacy in maximizing student talk time and enhancing oral production quality during synchronous classroom interactions using quantitative and qualitative metrics. To operationalize and embed continuous data-driven formative assessment protocols utilizing mobile and digital platforms, facilitating real-time learner progress tracking and adaptive scaffolding to sustain longitudinal oral proficiency development. The engine of our system is the strategic reallocation of cognitive load. In traditional classroom, teachers waste precious face-to-face time delivering lectures, grammar rules, and vocabulary lists. This is highly inefficient. In our model, we offload these lower-order cognitive tasks, remembering and understanding, to the digital LMS environment before class. Students study these modules independently at their own pace. This means that when they walk through the classroom, 100% of the face-to-face time is unlocked for active, higher-order communication, applying, analyzing, and creating. Let's look at the timeline of these 6 cognitive phases on slide 10. Here you can see the seamless timeline of our 6 digitalized cognitive phases. During the pre-class phase on the LMS, learners autonomously conquer phase 1 and 2, remembering and understanding. They absorb the linguistic inputs. The moment they enter the live synchronous classroom, the cognitive demand escalates. Under peer leadership, they collaborate to apply, analyze, and evaluate. Finally, they reach phase 6, create. This is where they synthesize everything they have learned to produce authentic, spontaneous spoken English. But how do we manage these classrooms without the teacher dominating the talking time? The secret lies in the next slide. To completely transform live classroom dynamics, we developed a proprietary approach called the tsunami method. Instead of a teacher standing at the front calling on one student at a time, we divide the class into active microgroups. Each group is led by a designated student leader. These leaders act as peer facilitators. They autonomously run interactive speaking tasks, keeping the conversational energy high like a wave. Because the speaking happens in small, peer-led groups, the teacher's direct talk time is systematically reduced. More importantly, this creates a psychologically safe space. Students are no longer afraid of teacher grading them, instead they are simply talking with friends. To ensure they speak accurately, we introduced the next element on the next slide. While peer-led groups are amazing for building confidence and fluency, we must also ensure grammatical and lexical accuracy. This is where artificial intelligence steps in. Our ecosystem embeds a device-agnostic, AI-driven corrective feedback loop. When students speak either during autonomous LMS tasks or recorded microgroup activities, the AI analyzes their speech. It delivers immediate, personalized feedback on pronunciation, syntactic structure, and word choice. This creates a highly personalized, interactive feedback loop. Students speak, get private feedback, refine their output, and try again. They learn to self-correct in a zero-pressure environment. So what happens when you implement this ecosystem? Let's look at the existing result on the next slide. The anticipated outcomes of this integrated model are highly encouraging. First and foremost, we expect a massive surge in student talk time. In our model, active learner speech is projected to occupy 75 to 80% synchronous class hours. This is a complete reversal of traditional teacher-dominated classroom. Furthermore, by moving oral production to student-governed microgroups, we dramatically lower their speaking anxiety. We achieve a beautiful balance. Pre-class studies scaffold their fluency, while AI feedback sharpens their accuracy. Best of all, this model democratizes the classroom. Passive, quiet students are transformed into confident, active speakers. Let's look at how we scientifically validate these outcomes. To ensure our findings are academically rigorous, we have built a comprehensive mixed methods data analysis framework. Quantitatively, we measure the surge in student talk time using systematic audio and video recordings. We use statistical analysis, including paired tests and repeated measures ANOVA to compare speaking time pre- and post-intervention. We also track emotional changes using the validated foreign language classroom anxiety scale. Qualitatively, we triangulate this statistical data with thematic coding from student self-reports and observational field notes. This rigorous framework ensures that our pedagogical claims are backed by solid empirical evidence. Now let us conclude. In conclusion, our research offers a highly scalable, transformative paradigm for higher education. By unifying LMS cognitive scaffolding, the peer-led tsunami method, and AI corrective feedback, We have created an open, modern ecosystem that directly addresses the challenges faced by language learners in developing countries like Uzbekistan. This is through digital intelligence in action. It is sustainable, it's highly adaptable to other modern languages, and it delivers a profound societal impact by giving our youth a global voice. Thank you very much for your time and your attention, and I'm now open to your questions and suggestions.